today we're going to be making some improv EDM with TidalCycles. So if you don't like dubstep or electro house, you're going to find this probably pretty annoying. You might find it annoying anyway, because we're going to be just listening to the same thing over and over a lot. Why are we doing EDM? It's not the first thing you would think of to write with Haskell. The reason is because EDM is really well structured and has an identifiable sound. So if we're making random bleeps and bloops, it's hard to sort of say, hey, did we succeed or fail? And also, it's a really good way to demonstrate the features that I want to talk about today, which are Tidal MIDI-In, which is these MIDI controllers, Novation 0SL Mark II, and a Keith McMillan keyboard, faders, buttons, knobs, keys. Pretty simple. So we're going to be demonstrating Tidal MIDI-In, which is actually Tidal accepts open sound control messages that you can store in variables and then use in your code live. And we have a SuperCollider script, I guess, that we're running alongside SuperDirt that's going to convert MIDI from these into open sound control messages that get sent to Tidal that get stored in variables that we can then use live. The kind of stuff we're going to use this for is controlling volume, low pass, high pass filters, toggling sections like instruments on and off, triggering whatever. I don't know if we'll actually get to that. But something cool that I really wanted to talk about, because it's super powerful, is the ability to send notes and, more importantly, chords into TidalCycles. So we're going to demonstrate some of that, and we're going to make some cheesy electro house stuff. So let's get going. The first thing we need to talk about is the SuperCollider script that makes this all possible. Like I said, Tidal only accepts open sound control, and you can access incoming open sound control messages using special functions. But we need to convert MIDI to open sound control and send it to Tidal. So TidalCycles, as you may or may not know, is a Haskell library for music patterning that talks to, optionally a number of different things, but primarily SuperDirt, which is written in SuperCollider, which is like a different thing for music. And that's a little bit too much to get into here. But you see this block right here, as we're going to initialize MIDI, we're going to connect to all devices, and we're going to create a socket that talks to Tidal. Tidal by default listens on this port at localhost. It's just loop back. And then for every MIDI CC value coming from any of our MIDI controllers, we're going to send a value that is between 0 and 1. So we're like normalizing the 0 through 127 values that are normally sent by MIDI. And we're also going to send notes. So what this is actually doing, and you can kind of see this here if you look closely, is that it's taking a global variable notes, and whenever you play notes, it's adding them to the global variable, and then when it receives note offs, it's removing them. But it's also sending those in a string to Tidal, and that lets us do some pretty cool stuff. But let's start with the MIDI CC stuff. Let's say, for instance, that we want to have, I don't know, let's like make a drum beat or something, right? Speed that up a little bit. Yeah, there we go. That's nice. Say we want to do something cheesy, like put a low pass filter on it and sweep it, right? Well, we could do this. We could say, actually I keep forgetting that the syntax got nicer with Tidal 1.0. I guess I should say easier. So we can 100% cutoff, just 100, like a brick wall. Or we could scale like a sawtooth wave. Well, that's not good. Oh, it got changed to range. Let's slow this down so we hear it a little bit. So that's nice if we want to just sort of have an LFO there, but what if we want to sweep it? Well, we can use a thing called CF. And CF, all it does is it takes an initial value, which we're going to set to, actually we're going to set it to 1. And it takes a string that represents the MIDI CC, oh, is it the route? I don't remember what it's called, but it takes the MIDI CC like message, just give it the name of whatever's coming in over open sound control. And in this case, all right, so we look at our MIDI controller here, say we wanted to map it to this knob here, and sorry, you can't see that, this knob. We hit edit, and this is how the 0 SL Mark II works, is you can actually assign all these things. This is CC number 8. So if we put this here, all of a sudden, we can sweep it. Oh no, did I screw that up? Nope, we're good. All right. See? Cool. We're sweeping. Excellent. All right, so that's kind of cool. It's all right. But what if we wanted to, for instance, insert some kind of a drum fill, right? But like only when we hit a button. Well, it's a toggle, so that's probably not good. We want a momentary button like this. So what we can do is we can write a little helper function, because right now we can't say this is on or off, right? But you can see that this outputs 127 when it's on and 0 when it's off, so it's going to convert to 0 and 1, because like we said over here, we are dividing by 127. Okay, so we can explain what we're doing here a little bit. We're saying, okay, so we get a thing called CApply that's going to conditionally apply this effect pattern to the incoming pattern at the end of this, which is implicitly sort of at the end of every, right? And so it's going to be based on this conditional pattern. And what we're doing to the conditional pattern is we're discretizing it, because these patterns that come in, they're like at a control rate where if you don't discretize them, if you don't like quantize them in time, then they're operating at such a high rate that they just cause everything to buzz unless you're really careful, like, right? Because you'll just, Tidal tries to combine the rhythms of various patterns coming in, and these have a rhythm of just constantly happening, which can make your stuff sound really weird. So this is going to limit the incoming open sound control messages to once per cycle, unless the pattern this is being combined with happens more often, and then it will query as often as that pattern happens, which is useful. And then what it's going to do is it's going to apply this function, which basically says if the value is above 0, then it's 1, else it's 0, which is useful because then we say every, and if you have every 0, then it's not going to happen, and if you have every 1, it's going to happen all the time. So let's see what we can do with this. Okay, so we made the default to 1 so we can hear what it's going to do. I guess we probably want this to be a bit faster. All right, so we're going to do a fill, and then we press this button, it's going to be on, we let go. Oh, so I'm trying to use CC9, which is a knob, and I want 40, which is a button. So if we use this, okay, suddenly we're taking the cutoff and we're setting it to full. we instead replace the pattern entirely, then we'll do the thing that I was trying to do to begin with, which is that's the wrong place for that. Okay, so now what's going to happen? Interesting. So we can totally change the pattern with the press of a button. That's pretty cool. Okay, so we can control filter cutoffs with knobs, and we can conditionally trigger stuff and affect patterns with buttons. But what about this thing here, right? What do we do with this? This is actually really straightforward. We've created an open sound control channel called Notes. And so right now we've been using CF, which takes floats. There's a CI that takes ints that we're not sending and may or may not be useful to you. There's also a CP. I assume the P means pattern. It actually like accepts strings, but I guess strings in Tidal usually represent patterns, so there we are. Anyway, we have a sound, I believe it's called Pluck Lead. It's one of our, oh no, I just closed our SuperCollider stuff. Here we go. So yeah, it's called donks and saw plucks and pluck leads. I don't remember if our saw pluck or pluck lead is what we want, so let's just use the pluck lead. Cool. Okay, so that's our pluck lead. It's a little bit loud, so let's take the gain down a notch or so there. That's still plenty loud, so let's take it down a little bit more. Alright, great. That's starting to get annoying very quickly. But what if we maybe give it a more interesting rhythm? That's better. And then what if we do, okay. That, and then we can kind of take the legato and extend it a little bit, maybe even more. Yeah, that's fun. Sure. But that's not very interesting on its own. How do we control it with this cool thing? It's really super simple. So what we do is, let me see if I can remember how we do this correctly. We're going to set the notes, and we could set the notes to a chord like this. And this is essentially what we're going to do. Except we're going to set it to CP, an incoming pattern. We're going to give it a default value of nothing, and then say we want to grab what's coming from piano. And now if we play a chord on the piano, oh, duh. It's called notes, not piano. And now, okay, cool. So we can control our notes with this. What if we wanted to add a bass line? Well, that's kind of an interesting conundrum we have, right? How do we add a bass line based on the chord we're playing? We have a bunch of notes. We just need to pick out one of them. Well, luckily, I think this is new to Tidal 1.0. There's a thing called mono. So if we want to get mono, let's say pluck lead, and then we can say, I don't know, 5 out of 8, 2, and then give it a legato of 4, sure, plus N, P. going to take the same stuff, notes, but we are going to run it into mono, and we are going to subtract about 2 octaves, let's say, from it. That's just too loud. And also, let's get a 4 on the floor bass line here. Right, that's pretty nice. So it plays the lowest note. That's handy. All right, cool. We can work with this. So with all that in mind, let's make some dance music stuff. Obviously, the most important part is to start with some solid percussion. So let's figure out how we can do that. We need a bass. Well, bass drum, I should say. And we're gonna increase the cycles per second, which is like the tempo, to 130 BPM. Standard has to be, let's do 132. Keep it interesting. Divided by 60. And then, of course, we need to actually send that somewhere. It's just gonna tell us that it is a pattern. And actually, we wanted 240. Did we want 240? Great, good and cool. So you got bass drums happening. So the next thing that we are going to do is we're going to add a snare. Great, but we still need hi-hats. That's a little bit too much. Perfect. And we could do this by separating these out, but you know what? I want to show you a cool little helper function. So we're going to fix the hi-hats because they're a little bit loud in the mix. It turns out that I had these swapped. So let's fix our fix. We can even give it a function composition. And high pass those hi-hats just a little bit. So now we have our electro drums. Great. What do we need next? We probably need some chords next. That would be nice, right? To have some chords. So let's do that. something that we probably want to do with these is we want to send them to orbit 1, which you can see I have set up. Well, maybe you can't see this because it's a little bit weird to look at, but I have it set up as a sidechain compressed channel with some reverb. It's sidechained to orbit 0, which is the default orbit. Orbits are like buses in Tidal. They're super dirt, both really, because one sort of doesn't exist without the other. Great. We want this on the offbeat. We want it faster. Cool. So use some electro-y sounding stuff, but we need a bass line. We could just have a bass line that uses the same pluck lead but pitched down and monoified, and that would be fun. And actually what we're going to do is we are going to, let me think about this for a moment. We're going to make a function called chordify. It's going to take a pattern and it's going to do this to it. And now we can chordify our leads. Now let's take a time out for a moment and listen to some samples we have. We have a whole bunch of fun bassline samples, and those are all in var bass. Oh my, that's very loud. Okay, so that's not great. But if we do this, well, that's a lot. So let's slow that down approximately by half. Fun. Okay, but we can't control those with N, because N actually for samples, it selects the sample, and if you want to repitch it, you can use up or speed. Up goes by up or down by a semitone, even though it's called up, and speed controls the actual playback speed, and they can both interact with each other. I tune these all to C, because that's really helpful, but pluck lead is not a sample. Pluck lead is a super dirt synth, so we can control it with N, and I think it might even support being controlled by up, but that's a different thing. And anyway, oh, okay, so now it's not playing anything, but if we hold down a note, okay, so maybe we should speed that up a little bit so we can hear it a little bit more clearly. That's pretty fun. But the thing we don't want to happen is if we decide to play a chord. I mean, maybe we do want that to happen. I don't. If you do, that's great. But now if we mono that, great. So maybe we should have a let bassify equals, I'm going to bassify a pattern. We say the pattern times up the mono CP notes. Great. Cool, cool, cool. And now we can bassify our pat. Well, hold on a second. Now we can bassify our pattern. I'm sorry that sound keeps on getting like that. It's because I have my system audio sidechained to my microphone, which is over here. It's on my desk because my boom stand broke, so... But anyway, so we've bassified this. So if we bassify this, we can then have a bass. We say let bass equals that, I guess. We can say let chords equal this. We can add some bass and some chords. Play that. Wow, that is some of those things are a lot louder than the other things. We also need to send our bass to the sidechain bus because otherwise it's like very sad because it just isn't playing there. That's fun. So we have something that sounds kind of electro housey. Where do we go from here? Well, clearly we need some white noise builds and we need some crash cymbals because otherwise, I mean, what are we even doing with our lives, right? Noise build is in here somewhere. It stretches itself out to fit whatever you want. It just makes a nice little noise build. And actually, if you reverse the speed, it makes like a nice little falling noise sound, which is also pretty handy. Those need to be slowed down quite a bit. So those could be slowed down even more. We're going to say like every 16 cycles or bars, I guess. We're going to have a build that leads into a crash. And that's nice. Okay, sure. But maybe we want to control all of these things individually. Or maybe we want to be able to control the gain of them. So let's make some tweaks. Okay, so our faders start at CC16. So let's just assign them one after the other to everything. So now we can control all of these individually. If we just want pads, and turn our noise down. By the way, the white noise is one long sustained note, so you're not going to be able to affect the volume of it until the next time it happens. I'm kind of slowly bring in the bass. Bring our white noise in. Crash in. Maybe if we're lucky, we'll hear the white noise before the crash, but probably not. So, could have been more helpful. So finally, because the sidechaining was so annoying and really, I feel like, kind of screwed up listening to a lot of the sound, I turned it off, and I'm just gonna screw around with a slightly different version of the script that I just wrote that includes some other fun stuff. So I guess let's get to it. All right, let's go.